In this video, we're going to talk about inscribed angles in circles. At this point, I want to make sure that you've watched the video or you're in class the day we talked about all the language of circles, because we're going to be using words like central angle, arc, inscribed angle, all kinds of things like that in this video. So if you haven't, go back and watch the other video. So first off, an inscribed angle, what is that? An inscribed angle is an angle whose vertex is on the circle and whose sides go through the circle. So you can see here this blue angle, its vertex B is right on the circle, and both sides of the angle go through the circle. All right, so it's got to be both of those things to be counted as an inscribed angle. Now, the inscribed angle theorem, we would have discussed this in class and did a little exploration, but it says an inscribed angle is always half the measure of the intercepted arc. And so this red arc is what we call the intercepted arc. It's just a piece of the circle that angle kind of like cuts off from the rest of the circle. So if this inscribed angle, let's just say this was 120 degrees, what that would mean is that this inscribed angle way in here is 60 degrees, right? And so what we could say, if we wanted to maybe put a little bit more general numbers in there, a lot of times you'll see like if this angle was theta, this angle would be 2 times theta. So there's two ways to write this. We can either write that the arc is 2 times the inscribed angle, or we could write it the other way around and say the inscribed angle is half the arc. And we could even write those in like algebra terms. You could write this like angle ABC in this case equals 1/2 of arc AC. I guess I should say 1/2 of the measure of arc AC. And then written this way, the arc AC, the measure of that arc, is 2 times the measure of angle ABC. I should put the little M's in front of those, shouldn't I? So the arc is 2 times the angle, or the angle is half the arc. Either way you want to think about it. And then one last thing I always want to mention is that arc is also going to be half the measure of the central angle, because the arc and the central angle are always the same. So if I were to draw this central angle in, that central angle would also be 2 theta. That's something we talked about in the first video. The central angle is always the same as the arc. So the central angle is double the inscribed angle if they intercept the same arc. So everything we're going to talk about today is just related to those, and I will probably say that a lot. But the arc is always twice the inscribed angle, or the angle is always half the arc. We can work forward or backwards there. So we're going to do a few examples here, and then we'll look at some specific cases. So on something like this, what I might be looking at is just to find what's the measure of arc DC and what's the angle measure for angle ADB. And so if I'm looking for this arc, what I need to remember is the arc is always twice as big as the angle. So the inscribed angle is 45. That means my arc has to be twice that, which 45 times 2 is 90 degrees. If I'm going to look at this one, this is just the other way around. If I want this angle, that is always half of the arc measure. So half of 76 would be, half of 70 is 35, half of 6 is 3, so that would be 38 degrees. All right. You could pull out a calculator and do that if you needed to. We could go a little bit further here and look at something like this. This takes a couple of steps. So here I see that we've given this 92 degrees for this arc right here. And what I also notice is that this goes through the middle. So that splits the circle exactly in half. That means that this arc here I can find by just taking 180 minus 92, which is 88. I know those two arcs have to add up to 180 because it is half of a circle, and a full circle is 360, half a circle is 180. Now that I know that this is 88, I know that my angle, my inscribed angle, is half the measure of the arc, so I know that x is 44 degrees. degrees. That angle is 44 degrees. Right? So the angle is half as big as the arc. The inscribed angle is half as big as the arc. The arc is twice as big as the inscribed angle. And then we can do some algebra here. That'd be our other way. So these ones are a little bit harder to think about. With this one, we can talk about a few different ways. So if I know that this inscribed angle is 51 degrees, I know that this arc right here has to be twice that. So that means it's 102 degrees. And so now this is also the measurement of that arc, so I can write an equation. 14x minus 38 equals 102, and I can start doing my algebra. Here I'd want to just, it's a two-step equation. Ooh. So I would want to add 38 to both sides. That gives me 14x equals 140. That's convenient. And I can divide by 14 and get 10. So if I know that relationship, 51 times 2 gives me 102. That's got to be equal to that one. So those are some examples you might see of problems that use this rule, this idea that the angle is always half of the arc, or the arc is always double the inscribed angle. Now, there are a couple other theorems that I don't like to have written down as special theorems because they are just special applications of this exact one. So the first one is what happens when the angle is inscribed makes exactly half the circle. Well, if I've got this angle here, and I know that this is exactly half a circle, because it goes through the middle there, or a semicircle is the fancy word. Well, I know this blue arc has to be 180 degrees, which means this inscribed angle has to be 90. So if you have an inscribed angle that goes exactly at half a circle, it's always going to be 90 degrees, but that's just because half a circle is 180, and the inscribed angle is half of that. Makes sense, right? If we have two angles intercepting the same arc, let's just kind of think of this through. If this angle was theta, we would know our arc up here would be 2 theta, because the arc is always twice the inscribed angle. If we looked at this angle would just be theta, because this angle is always half of that. And so what we notice here is that angle D is congruent to angle C. Two angles that intercept the same arc have to be the same, because they're always half of the arc. Their arc is the same, so the angles have to be the same. And then this one for parallel lines is actually pretty interesting. It has to do with our alternate interior angle. So if I draw that in, I know that that angle and that angle are equal. And if those two angles are equal, those two inscribed angles are equal, let's just call them theta. I know that my arcs have to be double that, 2 theta. So anytime I have parallel lines, I get equal arcs, just as a relationship or as a result of that alternate interior angles theorem from way back at the beginning of the year. Okay, last one, and this one actually did have you write down in your notes, is the inscribed quadrilateral theorem. And so we're going to go through and just kind of deductively talk about this, right? So if I look at this blue arc, I know that whatever that blue arc is, this blue angle is half of that. If I look at this red arc, whatever that red angle is, angle A is half of that. So the blue arc D, why am I doing the wrong colors? So the blue arc, which is arc DAB, plus the red arc, which is arc DCB, has to add up to 360 degrees, because that's a full circle. Those two arcs make the full circle. If I look at the angles that are inscribed, that intercept those, well, we know the inscribed angle is always half of the arc. So I just took that whole thing and I'm going to divide it by 2, which means angle, I should do this in the right colors again, the inscribed angles, in this case this is angle C plus angle A, has to equal 180 degrees. Because the arcs add up to 360, the angles have to add up to 180. And so in your notes, what I would do is draw this picture. Don't put all the reasoning there, but just put in your picture, add to 180. The opposite angles add to 180. And that is also true for this angle and this angle, right? Make sure you show that it's not all three that add to 180, but it's each opposite pair add to 180. Right? And so you're going to see some different questions. You might see something as simple as, there's a quadrilateral. This one is 80 degrees. This one is x. Well, 80 plus x has to equal 180, which means x has to be 100. I can just subtract, or I could solve an equation. Either way. But the more interesting ones here are some of the algebra ones. And so anytime you're writing an algebra equation, I always want you just to go back and think about, what do I know is true? So what do I know about that angle and that angle? I know they add up to 180 degrees. So I'm going to write that. 4y plus 14 plus 7y plus 1 equals 180 degrees. And now I can solve that. I'm going to combine my like terms. That's 11y altogether. I've got 14 and 1 is 15, and that equals 180. Then I can solve my equation. Minus 15 minus 15. 11y equals, it's a good thing I left Desmos open on this tab. So we're going to do 180 minus 15. That's 165. And then I can divide by 11 to see what y is. So 165 divided by 11 gives me 15. So y is 15 degrees. And I can solve just like that. So just as a review here, the most important rule on this whole thing is right here, the inscribed angle theorem. An inscribed angle, this blue angle, is always half the measure of the arc, which means the arc is 2 times the measure of the inscribed angle. Right? I would write something like these two things down. The arc is 2 times the inscribed angle. The inscribed angle is half the arc. That's the big thing for today. Everything else is just a result of that, like using that knowledge.